All right, so I'm taking this meandering walk. I've already sort of summarized the main points in the question. The fact that I'm going 5 kilometers east for 2 hours, then back a kilometer and a half for an hour and a half for 0.5 hours, and then east again for 10 kilometers in 2.25 hours. Question A is asking for the average velocity. We have a formula for that. The average velocity formula is equal to the total displacement, so delta x total, delta x being displacement divided by delta t. So the question is, what's the displacement? Because we need to know what the total displacement is. Okay, and the displacement, the total displacement is just going to be found by adding up the individual displacements. So delta x1, don't forget the vector signs here, plus delta x2 plus delta x3. This is where sign convention comes in becomes really important. When I'm walking the first 5 kilometers, I'm going in an eastward direction, and what we do, like I said in the handout, is we assign a direction a sign convention. So for example, in this case, I'm going to call anything that's going in the eastward direction positive, which automatically makes anything going in the westward direction negative. So what that does is it assigns a positive sign to the 5 kilometers, it assigns a negative sign to the 1.5 kilometers, and a positive sign to the 10 kilometers. So when I go to add these up, with vectors, you're always adding them, but in the case of directions, you're going to add, for example, this is going to be plus 5, and then when you add it, you're adding negative 1.5 because of the backwards, and then plus 10 again. So when I add it all up, I end up with plus 13.5 kilometers. And what that plus sign ends up meaning, that plus sign indicates, according to my sign convention, east. So my answer works, for the displacement, it works out to 13.5 kilometers east. And I can put those in square brackets. I'll just put it like that. It's all okay. So going back over to point A, it's going to be the total displacement divided by the total time. And what this works out to be is, so it's 13.5 kilometers east, because displacement has a direction, divided by the total time would be 2 hours plus a half hour plus 2.25 hours, which works out to 4.75 hours. So when I do that math, I end up getting, I think it's 2.8 kilometers per hour. And don't forget to include the direction, because velocity is also a vector and requires a direction. For part B, it's asking for the average speed. So the symbol for speed is v also, but without the vector sign. S is just a complicated variable. We don't really use it for speed. So we're going to say VAV equals, and again, distance is delta x also, but without the vector sign. So this just takes a little getting used to. You will get used to this eventually. It's kind of a pain right now, but like I said, I think you will. So here we're talking about distance, not displacement. Whereas here we're talking about displacement. Okay. So how do we find the total distance? Well, sorry about that. So what we do now to find the distance, it's going to just be the line segments. It's like the total length of the path that I walked. So the signs don't matter. So really what we have here is 5 kilometers plus 1.5 kilometers plus 10 kilometers. So that works out to 16.5 kilometers that I walked total, right? So then when I go to find my average speed, it's going to be 16.5 kilometers divided by 4.75 hours. It still takes the same amount of time, 75 hours. And when I calculate that, I think I end up getting 3.5 kilometers per hour. And I'm not going to include a direction because the average speed, it has no, speed has no direction. Okay, so these are our two answers. Average speed for part B and average velocity, VAV, for, this is our average velocity.